we have graphed growth and decay functions a little earlier in this unit. Now we are moving on to logarithms. So here's kind of what's weird about this. So when we're looking at these, I'm actually going to do this in the reverse order. So we're going to take a look at the growth function first. But before we do, to make sure we're all looking at the same screen, I need you to do a zoom 6, a standard, so we're all going to be looking at a 10 by 10. You will not have, you shouldn't have something. Why do I have something already? That's messed up. Don't want that. Okay, so once I get that to a 10 by 10, this is how I type in. So 10 to the x power. So again, there's your exponent button above the divide. So we got to get that in there. And we're just going to take a look at the sketch of it. We're not going to get fancy here. So I look, you're like, yep, growth, just like it was before. So growth, here it goes, there it goes. Okay. Now, logarithms are inverses of growth and decay models. So, when we're typing this in, we are going to go back to the y equals. Log has its own button here next to 7. So we're going to do log, and it puts a parenthesis in there for us. So we're going to put the x, and then we're going to close the parenthesis at the end. Does it matter? Technically, no, but it may in a little bit. So I'm just saying. So I go to graph this. Now, at first when I look at it, it looks like it's going like this. But there's a little small problem that we don't get to see, and we're just going to have to learn to know on our own. My log does not stop there. This is not a square root function. Okay, it's not a radical. This has gotten so close to its asymptote that you can't really see it that well. And so we've got to remind ourselves when we graph this that that keeps right on going down forever. So when you look at these, you're like, oh, it's kind of like I took my graph and I flipped it. And that's how logarithms in general are going to work. So here's where this gets kind of nice when we get to the graphing part, which I'm going to let you in on the secret here right away. Normally, or let's say you didn't have a graphing calculator that was one of the ones we had in class, okay? Normally what you would have to do to type this in, you wouldn't be able to type this in your calculator. Like I can't go to y equals and type like log 2 x, whoops, x. I can't, that is not that. Okay, bad. And erase it, I never saw that. What you would normally have to do here is you would have to do the log of x, okay, this of value, divided by the log of 2. Now that gets tricky, because what if I flip them? What if I forget to close the parenthesis? All this other stuff that can go on. So I found a better way on these calculators. So this is going to be much better. Here, check this out. So we're going to go to the math button here, right below alpha. So if you press in the math button, we are going to scroll and scroll and scroll. We are going to go all the way down to A, which says log base. And the reason this is so cool, and when I just saw this last week for the first time, I was like, dang, I needed this in my life for a long time. If you hit this, it kind of looks like this format, except it has boxes in the places. And it's as easy as plug the number in there, right arrow, plug the X in there. That will work. That's so much better. So once I get it typed in, take a look. Now, does it look incredibly different from the last one we did? Not really. I mean, if I pull up my chart, let's check into some stuff here. So we like to have whole number stuff better, but sometimes I may not be able to get it. So what I'm going to attempt to do, as long as I can get at least 3 values off my calculator that are whole numbers, hey, if I get a 4th, I'll take it. I'm going to go ahead, I'm going to use those, come over here to my graph. Again, x-axis y, so 1, 0, 2, 1, 4, 2, 8, 3. But here's the thing. Let me come back over here for a second. When I start seeing all these error messages and things again as I go to the left, like, wait, what's going on with all these? Error. That means this value doesn't exist over there. But what it tells you even better is, it tells you where your asymptote is. Wherever that first error message is, so in this case that's at 0, my asymptote is at x equals 0. So now, because before when we were doing growth and decay, our asymptote was always y equals. It was going this way. But now it goes vertically, and it gives me that place when I'm drawing my graph to know where my graph will start to run against it. It doesn't go through it. Don't do it. Do not go over the equivalent of a math electrical line. It'll burn you, literally. And so what you're going to see here is you're going to start finding patterns with these again. So let me explain. The asymptote is at x equals 0. Is domain or range x? Which one's x and which one's y? Okay, domain is x and range is y. The asymptote is x, so your domain will start at your asymptote. If you think back to the growth and decay, or you flip back further in your packet, you'll see the range was matching with my asymptote because they were both y. What the heck about the range then, Hardy? What's the deal? My range from bottom to top, we're going down forever, and we are very slowly but surely going up forever. Every single time when we are doing a logarithm. So domain and range have basically flipped places, is what's gone on there. And so for other things like end behavior, you're like, wait a minute, what the heck? Remember, f of x is just y equals. So when we were doing end behavior before, we were always talking about arrow to the left, arrow to the right. Well, now we're talking what happens when y goes up to positive infinity? What happens when y goes down to negative infinity? And yes, just like we had before, your domain values will match with these. So, as my y is starting to go up, my arrow is going to the right, forever to infinity for x. So as y goes up, as x goes to the right, y is going up. That's true. As y goes down, 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 down we go. We're getting closer and closer to this 0 right here. So it's like literally flipping our mindset from what we were doing on growth and decay before to now do it with this new area. And then our y-intercept, my x-intercept is going to occur when y equals 0. So I'm going to go to my chart. I'm going to find where y equals 0. And that coordinate point okay? Not x equals 1, it's not another asymptote, it's a point. And I'm just gonna steal that from my calculator. And that's gonna be it. So once I kind of start wrapping my head back around, okay, this is like the same but it's different, it doesn't end up being too bad of a thing to deal with. Now, there are a few twists and turns. I'm not going to tell you they're not because I'd be lying, and I don't like to lie. So I'm going to bounce around a little bit, though. I want you to see a twist right away. And then once we do a twist, I want to see if we're doing okay before I do anything else kooky. Okay, so let's flip over to do number 3. Go to my calculator. Again, if you wanted to do change of base, I don't know why you would, but if you did, you would do log x minus 1. Oops, I put too many parentheses. Log x minus 1 divided by log of 4. Now, I'm not going to actually do it this way in a minute. I'm just showing you again, if you're looking later. We're going to do the easy way. We're going to do math A, so math log base, and then I'm literally typing what I see, and when I get done in an area, I'm just going to press to the right. X minus 1. Press to the right. Look exactly the same, my little subscripts there. I can take a peek. Ooh, we moved a little bit to the right. Okay. So let's see what's happening here. Error, 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 error. Last error message that I see before the numbers start. There's my vertical asymptote. So before I ever start, so I don't screw this up, I'm going to stick that in there. And now again, I'm just going to go in here and I'm going to start grabbing points. So I got 2, 0. 1, 2, 3, 4, 5, 1. Do I get one more? Not really. I'm going to use that 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.5. Reminder again, when you're graphing, it looks like it stops. It doesn't. Don't do it. Sure. And now start making the connections. Asymptote is x. Domain is x. 1 to infinity. Or all reals. Well, no, I don't want to do that with this. That would get kookier. We better stick with this. Range every time on a logarithm. I'm going down forever, and I'm very slowly going up forever. Up and down. Again, I like to find the easy one. The easy one to me, because these two are going right here, is this, and I didn't label it, bad Hardy. As we're going down, we're going towards that x equals 1. As I'm going up, I'm going right forever. I'm just doing directions. Right as we go up, towards 1 as we go down. And I didn't mention this the first time, but I saw it when I was doing the chart. You even can see it right there on your graph if you stopped and looked a second and graphed first. You're like, oh, it crosses the x-axis there at 2. So 2, 0. As we're rolling those along. So don't let things get, too kooky on you here. But we don't want to get into all that. But as long as I can make a connection here and there, we're going to be all right. I got 2 left that I want to do. Yeah, we can do these. 2 left to do. It's detail stuff, but it's detail stuff we need. Okay. Detail on this guy. Math. Okay, I got this. Math A. All right. 3. Move over. Be careful. Like, why do I got to be careful? Because the only thing in the parentheses is the x. x. So like if you look at number 5, you see how it says x plus 9, the parentheses are there? Here, that minus 2 is outside. If I don't put it outside, I'm going to get a different graph than I did here. So that's the danger on this one. If I get around that danger, you're like, gosh, these all look the same. They do. It's true. So let's see here. I'm looking at my graph. Error message starting at 0. Because I didn't move left or right, I just moved up and down. That just doesn't matter to this. So I'm like, all right, x is 0. Let's get that in there.
What's up, Hardy?
How's it going?
Good to see you, man.
Nice to see you too. So 1, -2. 3, -1. I don't think I'm getting the third one. Oh, I did. 9, 0. Hug that asymptote. It won't hurt you unless you cross it. And now we do the stuff that just matches up again. Asymptote x, domain x. Bam. Range is always the same. I could have done that before I even looked at the graph and looked at the problem, so that one wasn't bad. X-intercept when y equals 0. And I think you're going to notice a pattern starting to develop here. One thing I like about logs, I got to admit it. You're like, wait, Hardy. Down always seems to be the number, and up always seems to be the infinity. Like, is that true every single time, that it's always going up to the right and down to this? The answer to that is, of course not. No, we can't have a pattern that's quite that obvious. So let me show you on my last one why that can change and what's going to make that change. So last one, so we don't get into bad habits. Ooh. Let's see if we can pick up a pattern on this one. All right, math A. All right, let's do this. 1/2, arrow to the right. X plus 9, that's all in parentheses, but the plus 4, you've got to write arrow first to get out of there. That plus 4 is not. So make sure the parentheses and everything is looking the same. Once you do, okay, we'll take a peek at this. Ooh. Now it's more looking like growth and decay. It's not, but it looks more like it. So here, I pull my chart, like, all right. Like, dang, Hardy, -9? Oofda. So my asymptote's at -9. So let's get some points in here. Maybe we can start to figure out what some of these patterns are that we're doing. Yeah, sure. Did I just flip all those points backwards? I did. What the frittata? -8, 4, Hardy. 4 is up. All right, let's try this again. 3, -5, 2. Okay, that's better. These points, you don't see them. They do not exist. I did not cross my asymptote though, so I'm not in too much trouble. So I'm like, all right, x to x. Ooh, now Hardy. So does the domain still work the same way? It does. Starts at -9, goes to infinity. That did not change, even though the graph flipped. The range is still infinite. The range is still infinite. Did not change. Now I start to look at this, and I'm like, ooh, man, I had to go a ways. There's my x-intercept. I just had to scroll a little bit. But here's where it finally changes a little bit. We've been so used to this going in this particular order every single time. Well, this time it doesn't, because as we're going up towards positive infinity, there's the up arrow. I'm getting really, really close to the asymptote this time. And as I'm going down and leveling out, I'm going forever to the right. So here's the deal. When there's a plus or minus number in the parentheses, that's where your asymptote is shifting. In number 5, it's the opposite. The opposite of positive 9 is negative 9. Up in number 3, the number in parentheses was negative 1. Where our asymptote go? Positive 1. It just flips signs. And so what we're going to do, we're going to start with some of this today. We're not going to go cray-cray. But use these. Actually keep these out. Don't just put them away. You're like, Hardy's done Yibber, and I don't have to think about this anymore. Yay. Yeah, don't do that. Don't do it. We are going to do, I'm just looking quick. All right, that's a bright idea. This is going to work out well. Yeah, actually, it's going to work real well. Okay, so the goal today is 1 through 4. So the 3 on the front, and then flip over to the back. You've got examples that matched almost these identically. So it's not the time to chill for the next 20 minutes. Try at least a couple, check them. The answers are online. I got them right up here too. You can see if things are going okay. And that way, if we need to ask questions and stuff, we can